What would it take to limit it to 2 degrees Celsius? Let me remind you of a couple of numbers. Pre-industrial level of CO2 was 280. Today we're at 389. Methane, we've more than doubled since pre-industrial times. Nitrous oxides, 15% higher. Fluorocarbons, the increase is all due to human activities. And so if you were to add all the greenhouse gases up, we're about 485 parts per million today. If I allow for the fact that we've put a lot of aerosols into the atmosphere, sulfate aerosols, that's given us a cooling effect today, thank goodness. And it actually brings us down to what we call a carbon dioxide equivalent of about 385, 390. But if India and China do what we've done in OECD countries, and that is decrease the emissions of sulfur from the burning of coal, you desulfurize the coal, that offset of 100 parts per million will rapidly disappear. Why would China and India want to desulfurize? Same reason we did in Europe and North America. Acid deposition has significant adverse ecological impacts. So what's the chance of being at 400 parts per million of CO2? You need absolutely instant action by all major emitters today. And we do stabilize at 400. You have a 50-50 shot of 2 degrees Celsius. If we get to 450, we've got a 50-50 shot, about 2.5. At 550, a 50-50 shot at 3, and at 650, a 50 shot of 4. A whole series of energy economists met a few months ago. Their view was, rightly or wrongly, there's almost no chance of being less than 650. I hope they're totally wrong, because at 650, it's a 50-50 shot at 4. And it means there's a 50% chance of it being greater than 4. So we really have to aim to truly decarbonize our energy system as soon as possible. What does that mean? There's no simple thing as business as usual, but if I take the central part of the projections for OECD emissions, you'd expect them to rise by about 60% over the next 40 to 50 years. Instead of increasing 60%, we need to decrease by 80%. We've literally got to decarbonize our system. Developing countries, instead of increasing their emissions, a central estimate by 140%, they probably could only increase them by 40, 50, 60%. Major changes in the way we produce and use energy. We need to put a price on carbon. We need technology transformation, and we need to mobilize behavioral change. It's not simply policy, it's not simply technology, and it's not simply behavioral change. We need all three. The technologies are already there today to start on the pathway to decarbonisation. We can certainly produce our energy more efficiently, more efficient coal-fired power plants, more efficient cars, reduce use of cars, mass transportation, better city planning, more efficient buildings. They all save us money. We can use more gas rather than coal, but it's a limited supply. It only buys us a few decades. More renewable energy, wind power, solar power, biomass power, wave power, tidal power. When we do produce electricity from fossil fuels, we need to capture the carbon dioxide before it's emitted to the atmosphere. It's called carbon capture. Then we need to liquefy the carbon dioxide, and we need to store it in depleted oil wells, depleted gas wells, and saline aquifers. So it doesn't mean to say we cannot use our fossil fuels. Coal is cheap. There's 300 or 400 years worth throughout the world. We can use it as long as we don't allow the carbon dioxide to be emitted to the atmosphere. Nuclear fission, clearly going to be a part of the solution in most countries of the world. India, China, the US, France, Japan, probably the UK. Won't be acceptable in Germany and some of the Nordic countries, but I think there's more and more of a move, and nuclear can be part of the solution. It will not be the solution. And we have to manage our forests, our agricultural soils much more efficiently. This simply shows that if you do put a price on carbon, $20, $50, $100 per tonne of carbon dioxide. It was a result of the economists in the Intergovernmental Panel on Climate Change. It suggested across all sectors, from energy supply to transport to buildings to industry, agriculture, forestry, there's a significant potential to reduce emissions of greenhouse gases if you put a price on carbon. It will stimulate more efficient use of our carbon. Let me miss this one, as I'm running out of time. This was really interesting, behaviour. Only about 50% of homes in the United Kingdom have adequate attic insulation. It's like literally leaving pound notes lying on the floor. If you were to put adequate attic insulation, it probably pays back between 1 and 2 years. If you put cavity wall insulation, for those houses that have cavity walls, it probably pays back in 2, 3, 4, probably 5 years' time. So why don't people do it? This is a very interesting segmentation of the UK public. It went from the positive Greens, they really care about the environment, and they'll do anything to limit their footprint on the environment, 18%. There's a concerned consumer, 14%. They also want to do the right thing. They're both willing to act, and they've both got the ability to act. Then you get to number 7 over there, the honestly disengaged. They actually believe climate change is a serious issue, but nobody is going to tell them what to do. They actually don't give a so-and-so. They're just going to go on as many vacations. They're going to have a house. They're going to leave the electricity on. They're going to do whatever they want to do. Why is this important? If you want to move to a low-carbon economy, it's not good enough to just generate the new technologies. It's not good enough to put the right policies in place. For the positive Greens, the concerned consumers, all you have to do is give them information. For the honestly disengaged, you have to regulate. The only way to get to those guys is to regulate. So unless you understand how society is segmented, you don't know what the policy tools are to make that transition to a low-carbon economy in this particular case. So what do we need? We need an international policy. It must be long-term. The Kyoto Protocol was 2008 to 2012. So one of the questions is, what do we need? Long-term, 2030, 2050, global, must be regulation, it cannot be voluntary, has to involve all major emitters, but it has to have an equitable allocation of responsibilities. China's emissions are equal to America's emissions today on an absolute level. They've now become the largest polluters in the world. But on a per capita level, they're only 20% of an average American. India is below both the US and China, and their emissions per capita are only 1/20th of an American. So you have to think through what is fair and what is an equitable allocation of responsibilities. Major issue for the politicians. It's not an issue that we scientists can give an answer to. That is a political decision. And so we need a long-term goal with intermediate targets. Why is 5 years not enough? Kyoto plus 5 doesn't send the right signal to the private sector to invest in tomorrow's technology. It doesn't send the right signal to the governments to put the policies in place to get the new technologies into the marketplace. It doesn't give the right signal to the consumer to actually start to change their behaviour. And so the key challenge is getting India, China, and most important of all, the US on board. If we don't act, the cost of inaction, as Nick Stern said, exceeds significantly the cost of action. The cost of action to stabilise at something like 450 parts per million of CO2 equivalent would probably cost about 3% of global GDP by 2100. Sounds a lot of money. Probably $20 trillion. It's almost irrelevant. What does that mean? Instead of the world's economy growing to a certain amount by the year 2000, it means we would have the same economic growth, but it takes 2 more years. In other words, while it sounds a lot of money to spend $20 trillion or some number like that over the next 50 to 100 years, it's a very, very small perturbation to economic growth. The cost of inaction far exceeds hundreds of billions of dollars a year, probably, the cost of action.